Hello and welcome to another math video. Today's question is asking us to find the derivative using first principles of f of x is equal to square root of 2x plus 1. So, remember our first principles formula here. That's going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so plugging in our function, what I'm going to do is I'm going to, wherever I see an x in my function, I'm going to plug in x plus h. Whenever and for this one, wherever I see an x, I'm going to plug in an x, so basically I'm going to leave it as is. Limit as h approaches 0. Here, for the first part, we're going to have 2 multiplied by x plus h plus 1. It's going to be the first part. I'm going to just put brackets all around that as well. No, actually, I don't need to. Sorry about that. Okay, there we go. So we have 2x plus h plus 1, and then we have minus, we have another square root, and this is going to be just 2x plus 1, and on the bottom, I still have my h, okay? So the goal here is I have to try and rearrange this right here in a way that my h on the bottom can cancel out with an h on the top, okay? Because as we can see, if we just plug in 0, can't divide by 0, so we cannot do this limit the way that it is right now. And this one, it's a little bit tricky, but if you guys recall your difference of squares, right? So the difference of squares is going to be something like a squared minus b squared. You can split that up into an a plus b, a minus b. Something that looks like that, right? Well, here we can do something very, very similar, but with square roots, okay? So if I pretend these are square roots, right? So if I write my formula out like this, if I have square root a plus square root b, and I multiply that by square root a minus square root b, that's just going to give me a plus b, like that, okay? It's sort of the same thing that we did up here, right? Except now these are square roots, and these aren't squared anymore, they're just to the exponent of 1, right? Because these are to the exponent of 1/2, now these are to the exponent of 1. Sorry, that's going to be a minus, it's my bad. Okay? So that's sort of where the concept that we're going to need to use. Okay, now the idea here is I want to get rid of these square roots on the top, right? Now if I want to do that, I'm going to use this thing here. I want to transform it into a form that looks like this, okay? But here, my a is actually equal to this whole thing, right? So my a is everything that's going to be under the square root here, so this first part here, so it's actually going to be 2x plus h plus 1, right? My b is going to be everything under this square root here, right? Because that's the second square root here that we're trying to get. So it's going to be 2x plus 1. So if we plug these into this formula here, we will get something. We will get this exact thing right here, but without the square roots. Okay? So, here's what we're going to do. I need a little bit more space on that side here. I'm going to multiply the top and the bottom by this. It's going to be 2x plus h inside my brackets plus 1 plus the square root 2x plus 1, right? Because we already have the minus. Now we need the plus to turn it into this form, right? So here's my plus right here. We're going to multiply the bottom by the same thing. So I don't want to change it, right? So if I multiply the top and the bottom by the same thing, we're not really changing this formula, right? We have the limit as h approaches 0. Now, multiplying these two out using our formula here, I'm just going to get a minus b. My a is this part here, so it's going to be 2x plus h plus 1 minus my b, which is this part, 2x plus 1. Right? All over, so I'm going to have h multiplied by this whole thing here, right? So I'm going to start a bracket, and I'm going to go square root 2x plus h plus 1 plus root 2x plus 1. Okay. So, everyone with me here? Now, further simplifying, right? Trying to get rid of this h. Limit as h approaches 0. On the top, we're going to expand this out. 2x plus 2h plus 1 minus, here we have 2x minus 1, right? Here, I still, oh, that's an h. Sorry. And here we have an h. And we have still everything left on the bottom, right? Okay. Moving on up here. We have the limit as h approaches 0 of, well, what do we have left here? Let's see. 2x minus 2x, those cancel out, okay? 1 minus 1, those cancel out. So all I have left on top is just 2h, right? So if I have just 2h on top, I can cancel out that h with the h on the bottom, okay? So all I have left up top is this 2, okay? So I have my 2 on top, and on the bottom, I have everything else. 2 x plus h plus 1 plus square root 2x plus 1. Okay? Now I no longer have that single h on the bottom. I have an h that's inside here, so we can try and work this thing out now. Okay? So if I plug in h equals 0, right, we're going to have 2 on the top. Here I'm going to have square root 2 multiplied by x, that's going to give me 2x. Then I'm going to have 2 multiplied by the 0, right, plus 2 multiplied by the 0, which is my h, right? And then we have plus 1, and here we have plus root 2x plus 1, right? So this 2 times 0 is just going to go away. So I have square root of 2x plus 1 plus square root 2x plus 1. Well, that's just 2 square roots of 2x plus 1, right? So I'm going to write it out one more time. 2 over 2 square root 2x plus 1. My 2's cancel out, and I just have 1 over square root 2x plus 1. That is our final answer there. Okay? A little bit tricky there, but you have to try and multiply by this part here using this formula. This is called the conjugate, okay? I don't know if you guys have run into this yet, but this is called a conjugate when you're trying to, it's a very useful tool when you're trying to get rid of these square roots here, right? And it all comes from this difference of squares formula. That's sort of where it's derived. And if you take your time very carefully, you'll get here. And if you try to do this derivative without using first principles, right? So just to verify really quick, let's try and do it over here on the side, right? So without using first principles, I have 2x plus 1, that's to the 1/2 power, right? Bring the 1/2 down, multiply by the inside to the negative 1/2 power, right? Multiplied by the derivative of the inside, right? Which is 2. My 2 on the top and the 2 on the bottom cancel out. This is negative 1/2, so I move that to the bottom, so I have 1 over 1/2 is just a square root, right? 2x plus 1. 1 over square root 2x plus 1. It works. Okay? Hope you enjoyed it. Have a good one.